In section 1.6, we're going to be working with graphing tangent functions and graphing cotangent functions, and also doing the graphs of secant and cosecant functions. And then we'll also be working on damped trigonometric functions, which you may find a little complicated, but we'll go through that and make sure you understand that the expectations are not crazy high in terms of how much detail you provide on these. Okay, so a tangent function looks very different than a cosine or a sine function. You see, it again has a repeating pattern, but it has some other things that we don't normally have. We have vertical asymptotes, and so we have vertical asymptotes that demarcate between the different periods, right? So this is a period, and you have asymptotes between each period. So the periods run between the asymptotes is basically the way it goes. And typically when we work with graphing and laying out the period, we're going to do it off a central point as opposed to with sine and cosine where we'd start on the left and work to the right. With tangent and cotangent, we'll probably start in the center and work our way out from the center to define the period. Okay, so its symmetry is around the origin. It has the same sort of domain issues, but it's a little different. It's a little different. The period is related to pi as opposed to 2 pi. So when b is equal to 1, so we would find period is equal to pi over b, whereas in sine and cosine it was 2 pi over b, so it's a little different. All right, so when we take a look at graphing something like this, in this case a is equal to 1, b is equal to 1/4. Right? So pi over 4 is the same as 1/4 times pi. That means that my amplitude is 1, but it's going to come into play a little differently here. And my period is going to be pi divided by 1/4, which would be 4 pi. Now we're going to start at the origin, and what we're going to do is we're going to move 2 pi to the right and 2 pi to the left. So I'm moving half the period in each direction from the center. And when I do that, that identifies my asymptotes. So I'd have asymptotes there, and 1, 2, 3, 4 more pi over that way. I'd have an asymptote, 1, 2, 3, 4, and on, right, to positive and negative infinity. Now, when we talk about the amplitude, this is going to be the distance to the next point. So when I'm working on splitting this into quarters. So I moved a half to the right, half of that is 1/4, and this would be my upper amplitude, and then over here I would do it in the opposite direction, and that's my tangent function. Okay, and if we wanted, we could duplicate this, and it would be in all of these places. Right? And that's sort of the way it works with tangent. So we're still working with the amplitude, but it becomes the coordinate of this point. So this point is at pi 1, and this point over here is at pi -1 when we're talking about these 2 points. Okay, it comes in along the left asymptote, passes through the 3 points we've defined, and it goes out along the right asymptote. Okay, so we're going to go ahead and do another one of those. My amplitude again is 1. And I want tangent of 2x, so it's going to be pi divided by 2. So my period is 1/2 pi. All right, so I'm going to make these large. So let's say this is 1/4, 2/4, 3/4. Let's say that's pi. 1, 2, 3, 4. And that's negative pi. Half a pi would be 1/4, half of the 1/2 pi period would be 1/4. So that would be here, and the other quarter would be there. So this period here is 1/2 pi. All right, and what we'll do is we'll put in our asymptotes from there to there, and then I'd go another 2/4, another 2/4. This one's going to be pretty narrow. Maybe I should have made my graph a little tighter. But again, we're centered here at 0. Halfway here, I'm going to go up by my amplitude, and halfway here, I'm going to go down by my amplitude. I come in along this asymptote, I pass through my 3 points, and I head on out. Okay, so that's graphing the tangent function. It's not that hard. Okay, and you'll see that cotangent is very similar. The difference is tangent came in, right? Tangent comes in from low and goes out high. Cotangent comes in from high and goes out low. But how you identify all the different points are still essentially the same. So in this particular case, my amplitude is 1. My period is going to be pi divided by 1/4, which is 4 pi again. So 1, 2, that's 2 pi, 1, 2, negative 2 pi. And this is 2 pi. And I'll put in my asymptotes. Right, 2 to the left and 2 to the right makes a total of 4 pi for the period. I know that when I'm here, my amplitude would be 1. And over here, it would be 1, negative 1. And I come in high, pass through my 3 points, and I go out low. And that's the cotangent function. Pretty straightforward. Right, now when we talk about graphing reciprocal functions, so cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. And what you'll find is that we'll have asymptotes everywhere the sine function would have crossed the x-axis. And then our graph ends up being parabolas that share the maxima and the minima, but in reverse. So when I go through that, you can see the minima of this branch of the graph is the maxima of the sine. And equally, the maxima of this branch is the minima of the sine. So what we'll do first is we'll sketch the sine function, and then we'll graph the cosecant function based on that. And the secant function has the same relationship with cosine. So let's go ahead and do one of those. Now we've got more stuff in here, right? So we've got, in this case, we've got the h. The amplitude is 2. I know I have h is equal to negative pi over 2, because this is x minus negative pi over 2. So that means a shift to the left. K is equal to 0, so there's no shift up and down. And what I'm going to start by doing is graphing this as if it was a sine function. So let me drop in some lines here. Okay, so I'm just adjusting this to get ready to sketch the sine function. So I'm going to sketch a number of different things, and I'm going to do my final graph in black. So the first thing I want to do is I'm going to graph the sine of y is equal to 2 sine of x minus negative pi over 2. So that means that rather than starting here at 0, I'm going to be over here at negative pi over 2. My b value is 1, so then my period is going to be 2 pi over 1, which is 2 pi. So when we go ahead and put that through, here's 2 pi, and here's pi. Here's pi over 2. This is, of course, 0. And this is 3 pi over 2. So when I look at graphing the sine function, it's going to start here. The amplitude is 2, so then it's going to come up here, then down to negative 2, and then back here. So this is my sine function. Okay, and I'm just going to graph one period of this. I want to put in my asymptotes. My asymptotes are wherever I hit the x-axis. Okay, so those are my asymptotes. And now my actual graph are going to be parabolas that come in along the asymptote, pass through, in this case, the maxima, or in this case the minima, and head back out. Okay, and that's how you graph a cosecant function. So I handled the shift when I sketched the sine function, and then all I have to add in is the asymptotes and the actual graph of the cosecant function. Okay, so let's take a look at secant. Right? In this case, my amplitude is 1. My period is going to be 2 pi divided by 1/2, which would be 4 pi. Yeah, I'm going to go ahead and, going to go ahead and drop in lines again so I can graph this. I have no translation, no reflection going on in this problem. So I'm going to go ahead and I'm going to mark this out as there's 4 pi, 2 pi, pi, 3 pi. And if I were to graph the cosine function with an amplitude of 1, it would be here, here to here to here to here to here. So it would look like this. Now I'm going to go ahead and go a little bit to the left and to the right just to get a little more of this. Right? So that would have gone down to here. So this is negative pi. And we could have continued on to here. This is 5 pi. And I'm going to put in my asymptotes everywhere I have intercepts. Okay, and if I want to go ahead and graph this now, I come in along the asymptote, pass through the maxima. Coming along the asymptote, pass through the minima. Coming along the asymptote, pass through the maxima. This is the graph of a secant function. Okay, very similar. As long as you know how to graph sine and cosine, it's an easy extra couple of steps to go ahead and do secant and cosecant. Right, so now when we look at damped functions, before I start graphing the damped sine wave, I want to show you what it looks like, and I want to show you its relationship to a couple other graphs. So this is what the graph looks like, and what I've graphed is our damped function, and you see it's the product of a quadratic function and a sine function, two functions being multiplied together. And here in blue, I've got the graph of x squared, and in the bottom, in green, I've got the opposite of x squared. And you can see how the damped function has a relationship there to that. Okay, so what we want to take a look at is how do we go about doing this and making it work out for us. Okay, so first I wanted to give you a look at it. We normally are not going to expect you to do anything more than about this here. Okay, so you can see that as it expands out, it keeps being bounded on the top and the bottom by the graphs of those other quadratic functions. It actually hits them. So if we travel up here, you see the high points here of the graph always are hitting that. Okay, but again, I'm not going to expect you to do a lot of points on something like this if I asked you to graph it. Let's go through how we would do that. So what I'm going to do here is I'm going to make an input-output table for x and y, but we're going to have more than one y. So here I'm just going to have the y for the x squared part, and here the sine of the 4x part. And over here, the one I'm actually going to want to graph, the x squared times sine of 4x. So what I'm doing is I'm just trying to make this a little easier. I'm going to just do 5 points here, similar to what we would do with a quadratic function. And when I take -2 and I plug it in here, I'm going to get 4, I'll get 1, I'll get 0, I'll get 1, and I'll get 4. Okay, but now, so when I plug into my calculator to evaluate sine of 4x, I need to make sure that my calculator is in radians. So I've got my calculator set for radians, and I'm going to have when x was -2, 4 times -2 is -8, and I find the sine, which is 0.989. Okay, 0.989, and that was negative. And then that item times 4 is -3.96. Okay, so we have -3.96. And I've got a point on my graph. All right, I'm going to go ahead and do the same for these other values. So when x was -1, I'm going to take the sine of -4. Oops, excuse me. 4 negative sine is 0.757. Or we can just say 0.76. So 0.76, and that's times 1, 0.76. And sine of 0 is 0. So here we're going to have zeros all across. And now over here we want the sine of 4, -0.757, and I'm going to multiply that times 1, so -0.76. And then we're going to want the sine of 8.989 times 4 is going to be 3.96. So you'll see that these guys are opposites. Sorry, positive 3.96. I'm sorry, this is 0.989, -0.76. Okay, and then we would go ahead and what I would graph is I would graph this with this. Okay, but I use this as a table to help me do all the different parts to create the input-output table. If we go ahead and check this for validity with our graph, you can see, oh yeah, there we go. Right, if we actually wanted to find -1, see we're getting the exact same values that I was working with before. Okay, and we could go ahead and go on and do as much of this as we wanted, but if you did the 5 central points, that would be just fine. So don't worry about doing too many points with this. Okay, it's mostly about understanding what's happening in my function. I have 2 functions that are being multiplied together, and I have to evaluate each function first and then multiply them. Okay, so just a quick review what our graphs all look like. Right, these are the graphs of y is equal to the sine of x. It has a domain from -infinity to +infinity. This is the graph of cosine, same, tangent, cotangent. Okay, when we get into the graphs of secant and cosecant, then you see they are inverses of the sine and the cosine. So it helps to make the sine and the cosine functions and then work off of those. Okay, so what have we done today? We've talked about the graph of tangent and cotangent, cosecant and secant, and then we went very lightly through damped trigonometric functions. And that's it for 2.6.